Okay, for this video, we'll be starting a new chapter called Turning Effects of Forces. So in short, it is also known as moments. Alright, so for this chapter, these are the following success criteria, 5 of them. I'll be going through maybe A and until B for this video. Okay, so for success criteria A, you must describe the moment of a force about a pivot. Just to let you know, pivot is actually a fixed point. Okay, in terms of its turning effect, and relate this to everyday examples, and recall and apply the relationship moment of a force is equal to force times perpendicular distance from the pivot to new situations or to solve related problems. Okay, so let's go through in detail. Now, we have already learned in previous chapters that a force is either a push or a pull, so it can that one object exerts on another. It can make the object move up, down, left, and or right. Alright, so it's always a straight line motion, either up, down, left, or right. That is the effect of what if we exert a force on an object. Okay, but when the force is exerted on an object which has a fixed point, sometimes we call it pivot or fulcrum. So we mainly use the word pivot. So pivot denotes a fixed point. When you see pivot, it is a fixed point. And sometimes we use a triangle to represent the position of the pivot. So we use a triangle to represent the position of a pivot, and this pivot is a fixed point, right? So when this force is exerted on an object which has a fixed point, the force can turn the object either clockwise or anti-clockwise. Alright, so this turning effect is then known as a torque or moment of a force. Moment of a force is normally used, torque is sometimes used, alright, but they mean the same thing. It is the turning effect. So we have actually seen this around. You have actually used this like opening doors. Like if I have a door here and this is the doorknob and we have a hinge, right? If we apply a force here, the door will turn, right? The door will either turn clockwise or anti-clockwise about the fixed point. These are the fixed points, right? So the door will turn. The door will not move up, down, left, or right. It will turn, right? So sometimes we turn on the taps. Okay, so example, this is the tap. Okay. Alright, so we turn this thing, right? So we turn it to open, turn on the tap, or turn off the tap. And also, if you look up, if you look at the ceiling fan, they actually have a fixed point, right? So the motor actually makes the ceiling fan turn. It applies a force about a fixed point. Okay, now this is the definition. You need to memorize this. Moment of a force is the product of the force F and the perpendicular distance D from the pivot to the line of action of the force. So it seems like this mouthful. There's a lot of unknown terms so far, unfamiliar terms. So let's go through one by one. Right, so for the first word is moment of a force is actually a turning effect. So moment causes something to turn. Okay, results in something turning. And next word, product, it means in math it is multiplication. Okay, multiplication. So what do we multiply? We multiply the force. We apply a force, okay, and we multiply this force to something. What do we multiply it? We multiply it to the perpendicular distance called D from pivot. Pivot is actually a fixed point to the line of action of the force. Maybe I'll explain to you what is line of action of the force. So we commonly use an arrow to show direction of the force, and if I have another force, so let's call this F1 and I call this F2, and you will see that F1 and F2, they are in the same direction. Okay, but F2 has a longer arrow, so F2's magnitude is larger than F1's magnitude. So maybe I give a number. So F2 maybe is 10 Newton. So F1 will be less than 10 Newton, maybe 7 Newton. Okay, so with an arrow, we can actually show the direction of the force. And if we do a length comparison of the arrows, we can see that F2 actually has a larger force. All right. Now, what do we mean by line of action of the force? So if I have a force that is represented by this arrow, okay, the line of action of the force, it is actually an imaginary line. Line of action of the force is an imaginary line. Please write this down. It is an imaginary line. All right, that you extend from the back and front of the force. Okay, so it is very safe to say that if I have a force presented this way, the line of action of the force, it is an imaginary line. You take a ruler, you draw the front and the back and extend this force in this direction. Okay, so why do I use dotted line? The dotted lines will show imaginary, right? It's not actually the force, but it is the line of action of the force. So this is the line of action of the force. Okay, so what does it mean? So if I have a person standing in this way, right, and if I apply a force in this direction, this person, let me call it person A, he will get hit. But if somebody is over here, person B is here, because the line of action doesn't pass through person B, right? It doesn't even touch person B. So B will not be subjected to the force, right? So basically it is an imaginary line, okay, that you extend the force. Okay, and my advice is that you always draw this dotted line. Okay, so now we have covered moment. We have covered product. The force is going to be multiplied to something. We have covered line of action of the force. So the last important thing is this, the perpendicular distance D from the pivot to the line of action of the force. We have also covered pivot. Pivot is actually a fixed point. All right, so let's look at this diagram here. Just now I told you that the pivot will be represented by a triangle, right? Okay, and maybe I have a rod here. Okay, I have a rod here. So this thing is the rod is being fixed at this fixed point called a pivot. Now, if I apply a force here, so what do we usually do? We extend the force using an imaginary line, a dotted line, front and back of it. Okay, I'll give you another example. If I apply a force here, this red arrow, what do? I will need to extend the force with dotted line, and the dotted line will show me the line of action of red force. So you always extend the line. Now, I'm looking for a perpendicular distance from this fixed point to the line of action of the force. Okay, so the perpendicular distance is actually this, the D that is written here. Simple, right? Because basically you have learned in math. Okay, let's go through a little bit about math. If I have a point here, right, and if I have a line, how can you tell me which is the perpendicular distance? A, B, or C? Okay, I'm looking for the perpendicular distance. Okay, and you would easily see that it is B, right? You can actually make out a right angle over here. So the distance is, this distance D is actually the perpendicular distance of the line to the force, to the fixed point. Okay, to the fixed point. I say again, this perpendicular distance, it is from the line to the fixed point. And you would have noticed that line B, or this distance D, is actually the shortest distance. Okay, let me do another example. I use this fixed point. Okay, I have another line here. Now, which one will be the perpendicular distance? Is it A, B, or C? So for this blue line here, okay, the perpendicular distance would be shown by A. Yes, you can make out that there's a perpendicular distance. There's a right angle over here that is joining the line and the point. Okay, and also it is the shortest distance. Now you can actually see that these two examples are quite simple. Okay, so now to test whether you understand this, I'm going to have a fixed point here. Okay, so this is my fixed point. Let me call this the pivot. Alright, and I'm going to draw a line. I'm going to draw a force. Now, where is my perpendicular distance? I'll need you to find a blank space somewhere. Okay, copy roughly what I have written here. I have a pivot. I have a force F. Okay, don't have to be too exact, but I will need you to try to locate the perpendicular distance. Okay, you may want to pause the video now. Okay, I hope you have tried it. Okay, so this example is not that straightforward. Okay, but if you had done what I taught you to do, which is to draw the line of action of the force, which is to extend the line, but this also doesn't help, right? So I need to extend it to the back. So for your line of action of the force, always draw from the front and the back. Always extend it from the front and the back of the force. Okay, so once you have this is the line of action of the force, and this is my pivot here. Where is the perpendicular distance? You wouldn't make the mistake, okay, because it's very simple now. You will find your perpendicular distance. Okay, so what you have seen me do, you see me draw my line of action of force, and it's very simple. Okay, but if you don't draw your line of action of the force, this is another example, a lot of you will think that this is the perpendicular distance. Okay, so let's go through this again. We always extend the force with a dotted line to show the line of action of the force, and once you have this, you would then know that this is my perpendicular distance, and this line is definitely shorter than this. So your perpendicular distance is always the shortest distance between the pivot and the force. Okay, let me type it for you. Okay, the perpendicular distance between the pivot and the line of action of the force is always the shortest distance. Okay, so please remember to extend the force with a dotted line front and back, okay, to show the line of action of the force. Because once you have drawn the line of action of the force, it is then very easy to determine this perpendicular distance. Okay, so let's go back to the definition of moment. Okay, moment of a force is actually the product of the force. You take the force, you multiply by the perpendicular distance d, okay, from the line of action of the force to the pivot, or from the pivot to a line of action of the force. That means I'm looking for that perpendicular distance. Okay, so we have this formula which is very important. Moment is equals to force times d, and d is actually perpendicular distance. So if you want, you can rewrite this as moment equals to force times perpendicular distance, to remind yourself that it is not just a distance, it must be the perpendicular distance. And how do I get the perpendicular distance? Always extend the force with a dotted line to show the line of action of the force. Okay, this is very important. A lot of mistakes were made because they didn't extend the force. Okay, some things for you to take note. SI unit of moment is Newton meter. Okay, because this is the Newton is the unit for force, meter is the unit for perpendicular distance, SI unit. Okay, but sometimes you can also express it as Newton cm. That means your perpendicular distance do not need to be in meters, it can be in cm. Right? But if the question do ask for SI unit, please leave it in Newton meter. Now, from the definition of moment, we can see that if the force is increased, the moment will also increase. Now, let us use the formula to help us. Moment equals to force times perpendicular distance. Okay? If the force is increased, the moment will increase. Yes? Now, if the perpendicular distance from the pivot is increased, okay, so now I change my perpendicular distance, I increase it. My force remains the same, force multiplied by a larger perpendicular distance, my moment will also increase, right? So this explains why it's easier to open a door if the doorknob is fixed further away from the hinge of the door, because in this case I am increasing the perpendicular distance of the force to the pivot. Therefore, it will result in a larger moment. Okay? Actually, you have done this in real life, right? But just to put it into science concept, it is moment equals to force times perpendicular distance. Okay, now take note that a moment is a vector quantity. Still remember what is vector? Vector must have both magnitude and direction, right? Because you can multiply force and the perpendicular distance, you will get a certain number. Now, the direction is now either clockwise or anti-clockwise. Okay, it's either clockwise or anti-clockwise. Now, moment will not be up, down, left, right. Force will not be clockwise or anti-clockwise. Okay, so force can be up, down, left, right. It can move an object up, down, left, right. Moment will either be clockwise or anti-clockwise. Okay. Now, to do well for this chapter, an important point is to know how to find the perpendicular distance of the line of action of the force to the pivot. This is very important. Okay, if you are able to always find your perpendicular distance, then you will be able to do well for this chapter. Okay, so now I will need you all to try B1. Okay, I have L-shaped rigid lever arm. Alright, so 6 forces act on the lever arm. What is the magnitude and direction of the moment of each force about pivot P? Where's pivot P? Where's the fixed point? It is over here. Okay, so let's do each force one by one. Okay, I will do with one example and then you will try the rest. Alright, so A is 5 Newton. Now 5 Newton is over here. Okay, and remember, Mr. Lee says when you have a moment question, always extend the force. Okay, always extend the force. Okay, not all questions will have so many forces and so many lines to confuse you. But for start, if I were to just focus on the 5 Newton here, okay, first thing, you always draw your line of action of the force. Okay, so extend it no matter what. Okay, once you have extended it, then pivot is over here. What is the perpendicular distance? It will then be this distance, isn't it? So this is the perpendicular distance for 5 Newton. Okay, so let's do some math here. The total length of this rod is 4 meters because it is 3 meters plus 1 meter. So they have a total length of 4 meters. From here to here, it is actually 2 meters. So the perpendicular distance for this 5 Newton will then be 2 meters. Right? So the moment equals to force 5 Newton times perpendicular distance of 2 meters. And I will get 10 Newton meter. Okay? So for the direction, it's easier for me to do face to face with you all. So it will be good if you can just calculate the magnitude. Direction I will go through when I see you. Okay, so can you all try for A, B, C, D, E, F, and for the next lesson, when I see you, I will go through the answers and I will teach you how to find the direction.